Matrices. We're going to learn how to add and subtract and multiply matrices. But before we do that, let's define what a matrix is. So a matrix is a rectangular array of terms. Here's a matrix of some numbers here. Notice that it has 1, 2, 3 rows and 2 columns. And we always talk about the dimensions of a matrix in terms of rows and columns. So this would be a 3 by 2 matrix. It has 3 rows and 2 columns. Now, how do we add matrices? Well, notice that this term is in the first row, first column. I will add it to the first row, first column term in matrix B. And then I'll do the same thing for the first row, second column, and so on. So A plus B is going to be 2 plus 5, -2 plus -2, and 3 plus 6, 1 plus -2, 3 plus 3, and -4 plus 5. And when we simplify that, we're going to get 7, -4, 9, -1, 6, and 1. Now notice that I can only add matrices that have the same dimensions. So this is 2 rows, 3 columns, and this is also 2 rows, 3 columns. So I'm able to add them together. Subtraction works the same way. So I'm going to subtract first row, first column in this minus first row, first column in this. So A minus B is going to be 2 minus -1, -3 minus 2, -1 minus -4, 2 minus 1, 2 minus 3, and 4 minus -2. Okay, a zero matrix is just what you think it is. It's just a matrix consisting only of zeros. And if I add or subtract a zero matrix from another matrix, nothing changes. So here are some properties of matrices. The adding of matrices is commutative, meaning it doesn't matter what order we add them together. It's associative. It doesn't matter how we group them. If I add the opposite of a matrix to itself, I'm going to get the zero matrix. And if I add a zero matrix to any matrix, I'm going to end up with the same matrix. So that takes care of addition and subtraction. What about multiplication? Well, there are actually 2 kinds of multiplication with matrices, and the first one is scalar multiplication, where we just multiply by a constant. So if I have a matrix A, this is a 3 by 3, 3 rows, 3 columns, and if I multiply that by 3, then what that means is I'm going to take every term inside the matrix and triple it. So this is going to be 6, -9, 3, 9, 3, -6, 3, -3, 12. So when you have scalar multiplication, you just multiply every term inside a matrix by that constant or that scalar term. So let's put it all together and let's do scalar multiplication and addition. So given these 2 matrices, we're supposed to find 2a plus 5b. Okay, so 2a is going to be -4, 6, 8, -4, 0, 8, and 5b is going to be 40, -10, -15, 10, -20, 35. When I add those together, I'm going to get -4 plus 40 is 36. 6 minus 10 is -4. 8 minus 15 is -7. -4 plus 10 is 6. 0 minus 20 is -20. And 8 plus 35 is 43. So that is twice matrix A plus 5 times matrix B. Okay, so we know how to multiply by a constant, but what happens if I want to multiply 2 matrices together? This is a little more complicated. Okay, now let's look at our dimensions. This is 2 rows, 3 columns, and this one is 3 rows, 2 columns. In order to multiply matrices together, the columns of the first matrix has to equal the rows of the second matrix. These middle two numbers have to match. And the result, the product of the multiplication, will be the outside numbers. So when I multiply A times B, I'm going to get a 2 by 2 matrix as its result. All right, so here we go. I'm going to write out matrix A here. And I'm going to put in matrix B. Okay, now I'm going to multiply the first row of matrix A by the first column of matrix B, and that will go in the first row, first column position. As I multiply these terms times these terms, I'm going to add them together. So I'm going to go 2 times 1 is 2, plus negative 3 times 4 is negative 12. So I have 2 plus negative 12 is negative 10, plus 0 times 3 is 0. So that was first row, first column. In the first row, first column position, I put negative 10. Now I'll do first row, second column. So that's going to go in the first row, second column position right here. Okay, 2 times 0 is 0, plus negative 3 times negative 2 is positive 6, plus 0 times 5 is 6. All right, now drop down to the second row, and I'm going to multiply that by the first column. Second row, first column will go into the second row, first column spot in our product right here. So 4 times 1 is 4, plus 6 times 4, that's 24. So I have 4 plus 24 is 28, plus negative 1 times 3. So that's 28 plus negative 3 is 25. Okay, last one. Second row, second column. 4 times 0 is 0. 6 times negative 2 is negative 12. 1 times 5 is negative 5. So I have negative 12 plus negative 5 is negative 17. So that is the product of multiplying matrix A times matrix B. And you'll notice, just like we predicted, we got a 2 by 2 matrix for our answer. Now the identity matrix is a special kind of matrix that when you multiply any matrix by it, you end up with the same matrix. And it's always a square matrix, and the diagonal terms are 1 and all the other terms are zeros. Okay, so this is a 3 by 3 identity matrix. You could also have a 2 by 2 identity matrix. Just make sure that the diagonals are 1s and everything else are zeros. When I multiply any matrix by the identity matrix, nothing changes. I keep the same matrix I started with.